Hi, Shaker students. This is Mr. Thomas. I'm going to be taking you through these slides from February 23rd and helping you to review some of the concepts that we need to understand for our unit in geometry. So let's start on slide number 1 and take a look at the first question. So in this question, we have a garden in the shape of a rectangle, and it has a width of 18 feet and a length of 35 feet. The garden requires fencing to be placed all around it at a cost of $7.50 per foot. It also requires soil to be placed over the entire surface at a cost of $3.50 per square foot. So to calculate the cost of the fencing that surrounds the garden, will we need the perimeter or the area of the garden? And explain. So take a second and think about that. If we were going to surround the garden, which is that? Is that perimeter or area? And how do you know? So in this case, that is perimeter. Perimeter is the distance around something. It is a linear distance. So the perimeter is the distance around an object, and it's linear, meaning in a line. Next, we have to calculate the cost of the fencing. So to find the cost of the fencing, we have to find the perimeter. So first, what would the perimeter be? How are you going to find it? Take a second to calculate your perimeter. Good. Okay, so hopefully you remembered that perimeter, you have to take 2 of the lengths and 2 of the widths and add those together. A rectangle has 4 sides, and you have to add up all the sides. So one side was 35, and the other side was 18. You have to multiply 2 times 35. You have to multiply 2 times 18, and you have to add them up. That's going to give you the total distance around the outside of this shape. So 2 times 35 is 70, and 2 times 18 is 36. So that is a total of 106, and that's going to be 106 feet. It's a linear distance, so it's linear feet. Now that you know the distance around the surface, around the object, if it's 106 feet, we still have to multiply that by the cost for each linear foot, which is $5.75. So go ahead and calculate that very quickly. What is the total cost going to be? And I might even throw the dollar sign in here so that I have the units and I know exactly what I'm talking about. So grab a calculator and calculate that. What is the total cost? Good. So you should have gotten $106 or $609.50. So that's the perimeter, distance around something. Part C says to calculate the cost of the soil to go inside the garden, will we need perimeter or area? And explain that as well. So take a second and answer that one. So since we just did the perimeter, there's a good guess that this is the area. But area is always the space inside an object. So since we're filling up inside that fenced area, that's going to be area. So next, find the area and find the cost. So first of all, area, we remember, is length times width. And in this case, the length is 18 and the width is 35. So you can grab a calculator and multiply 18 times 35 to get a total of 630. Now that 630 is measured in square feet. I'd say square feet this way, just to make it easier to type. But you could also use an exponent for the feet. And that's the way you would write it with a pencil usually. So now that we know that it's 630 square feet, you have to multiply that by the cost per square foot. And you know it's $3.50 for each one. So what is the total cost? All right, so it looks like it is $2,205, which is a lot for dirt. So that is an example. A lot of people do yard work and they have to put in fences or fill in areas. So it's not unusual to have to do calculations like this. And it's important to make sure that you understand the difference between perimeter and area. Let's take a look at the second shape because this is a little bit more unusual. We have to calculate the area of the figure shown below and show the calculations that you use. So first of all, it says the area. So we have to remember which formula we're using, and we're going to use length times width. But the problem is that this is an unusual shape. So let's start by creating two simple rectangles. Where will you cut the shape? So this is your choice. You can do either one and be the same. It'd work either way. You can cut it horizontally, or you can cut it vertically, but you want to cut it into two separate rectangles. Which one would you cut, horizontally or vertically? Me personally, I think I would cut it right here. And now I have two rectangles. So what are the dimensions of these two rectangles? Well, the one on the left is pretty easy. That's 21 times, or 22 times 31. And the other one is a little bit trickier. We know that this side is 16, but this side right here doesn't have a label on it. So that makes it a little bit more challenging. But you do have all the information you need because you know that the length from one side to the other is 55. And we know that this piece over here is 31. So now we just have to subtract those two numbers to figure out how much is left over. If the total distance across is 55 and the first piece is 31 across, then the remaining distance over here is going to be 24 centimeters. All I did was 55 minus 31 to figure out that remaining distance. So now I can label my dimensions for that smaller rectangle on the right, and I get 16 by 24. Now that you know the dimensions, calculate the area for each one. What would you get for the area of each one of those things? Well, the first one would be 22 times 31, that's 682. And again, that's square feet because it's the area. And the second one is going to be 24 times 16, which is 384, and it's square feet. So to find the total, you just have to add up those two things, and you get a total of 1,066 square feet. So we went over perimeter and area of regular shapes. We went over finding the area of a more unusual shape. We call this a composite shape because it's a shape made up of two simple shapes, and we just break it up into smaller pieces. So let's review really quickly also triangles, which is one of the most common shapes that you'll find in all of geometry because you can break up almost any shape into a triangle. They're hard to deal with in rectangles because they're not guaranteed to contain a right angle. When they do, though, both their areas and perimeters are easy to find. So find the perimeter. Well, we already know perimeter is when you do what exactly? Exactly. Add up all the sides. So all you have to do is 6 plus 8 plus 10 to find a perimeter of 24 feet. And it's not square feet because you're just measuring a distance around the outside. So how could we use a rectangle to help calculate the triangle's area? Well, we know that a triangle is half of a rectangle. And if we know that length times width is the area of a rectangle, just have to find the length times width. To find a triangle, you take the length and the width, length times width, and you divide it by 2. So we know that a rectangle is length times width, which if this were a rectangle, it would be those two perpendicular sides. 6 times 8 would be 48. But a triangle is a rectangle that's been cut in half. So if 6 times 8 is 48, you divide it in half, and you get an area of 24. So 6 times 8, but then you divide it by 2. You get a total area of 24 square feet. So multiply the two sides that are perpendicular and then divide it by 2, and that's how you get a triangle. So again, here is another triangle. Right triangles can always be thought of as half a rectangle. So last year, I know you saw that we can extend this to all triangles if we know their base and their height. So base times height. Now for this one, we have two ways to think about it. You could think about it as two small triangles or one big triangle. So part A says, find the area of MNP by finding the areas of MQP, this one on the left, and NQP, this one on the right. So let's do that. Let's find the area of the left triangle first. Base times height divided by 2. Base times height divided by 2. So what would that be? That's 10 square feet. And the other one, again, base times height divided by 2. The base times the height divided by 2. 6 times 5 divided by 2. And that gives us a total area of 30. Again, area is always in square feet. It says find the areas of each rectangle and then sum them. So sum means add them up. The one on the left is 10. The one on the right is 30. That's a total of 40 square feet. So we could have found the total area by finding the area of the left and the right, but we can also find it simply by multiplying the base times the height and dividing it by 2. So the entire base is 10, and the height is 5. So if the base is 10 times the height of 5, and we still divide it by 2, that would be another way to find that total area. I never divided by 2. That should have been 15. That's why this didn't work. Good. So now our total area is 25. And that's what we get down here too. 10 times 5 is 50. Divided by 2 is a total area of 25 square feet. All right, last one. Find the area of the following triangle to the nearest square foot. Again, base times height and divided by 2. It's always going to be for area of a triangle, base times the height and then divide it by 2, because a triangle is always half of a rectangle. So use that formula, find the area of this shape, and then continue on to the next few slides and work on your own. On the last 2 slides, they're going to be irregular shapes, which means you're going to have to cut them up into smaller pieces before you can find those areas. So go ahead and take the remainder of your time and see if you can finish up those slides on your own.